In the last video, I talked about variation and how it can affect quality, but I never clearly said what variation exactly means. So in this video, let's try to understand what variation is and when it becomes unacceptable. To do this, let me start with a very simple example. Let's say we need to manufacture a bolt of 5 mm. In real manufacturing, like I said before, expecting every bolt to be exactly 5 mm may not be practical. So the design gives us the tolerance, thank God. Now the specification limit for the bolt will range from 4.9 mm to 5.1 mm. So after production, if one bolt is at 5 mm, the other one is at 4.9 mm and the another one is at 5.1 mm, we can clearly say based on the measurements, these parts are not identical, but there is a small difference. This difference we call it as variation. And so when this variation will become unacceptable. So if the parts that we produce are at the dimensions, let's say 4.7 mm or 5.3 mm or 5.7 mm, then we can clearly say these are way beyond the specification limits and these are completely unacceptable. So whenever we get these kind of parts, they clearly lead us to scrap, rework, defects, or they may fail during the use. So with this bolts example, it is very clear that whether the product is acceptable or not will be based on the specification limits. But there is one limitation with this process. Let's say if we are trying to produce these bolts in a bulk quantity, and if we check these results at the end, we may have already produced more number of bolts way beyond the specification limits. And this process is not effective when we are trying to produce large number of quantities. So this was one kind of challenge Walter Shewhart was working at Bell Telephone Laboratories. When they were trying to produce a large number of telephone components, they not only wanted to inspect the final parts, but they also wanted to study the process of production while happening, because it will help them to get the consistent results all the time. So to do this, there must be some kind of idea. Then Walter Shewhart came up with this idea called the beautiful control chart. So what exactly are these control charts? So the control charts will help engineers study the process data over time, and they may identify when the process may need investigation. I am talking about control charts only briefly here, but we can understand more about it in our upcoming videos. To achieve the right results consistently, quality must be implemented in each and every part of the process. That is starting from the design to procurement of raw materials to production till service. So quality mindset should be like this: how we can improve the process. So it can be done in two ways, either through continuous improvement or by major breakthroughs. So depending on the type of problems that will arise, the engineers will use different kinds of tools such as Pareto charts, fishbone diagrams, failure modes and effect analysis, and root cause analysis to identify the defects and always try to improve the overall performance of the system as a part of continuous improvement. So coming to the major breakthroughs, the quality can be improved with the help of automated inspection or through AI vision or by using advanced robots. But in both cases, the process is still the same. Improve the quality, get the better results, make the process more reliable, and always meet the customer needs. That is how quality engineering will help us understand, control, and improve the process using the right tools. Thank you.